In the last lesson, we coded the get methods. We had get all words and also get word by ID. In this lesson, we're going to go on, and now we'll do the post method. For post, this will be an add word. When the user wants to add a word to the dictionary, they'll send a post request. And in the body of the post request, they'll have the JSON, which will include the word and the word's content. So we're going to bind the body. And we'll cast it as a word. And we'll call it new word. We're going to ignore whatever the ID in that word is, because when we add the word to the database, PostgreSQL will automatically increment the ID. Okay, let's create the query. It will be a query of word objects. We'll pass in the context. And we're going to set the values, that is, the column values, to whatever is included in our word object. Then we'll insert the word. With query.insert. That will give us back the inserted word, which will include the ID. Don't forget a wait. I always forget a wait. Okay, let's pass that map into the response. Aqueduct will convert it to a JSON string. Let's set the limit at 10 so we can see all of the results. Restart the server. In Postman, first let's do a GET request. Let's get all of the words in the database. There are only 5 of them right now, sorted alphabetically. Let's do a new request. This one will be a post request. The host will be localhost, the port 8888, and the path will be words. We need to set one header, that is the content type. We're going to be sending JSON, so set the value of the content type header to application/JSON. Now to get the body, we're going to send the word as a JSON string. Rather than typing it all out by hand, let me go over to the migration file and get a copy of one of these that we already entered in the database. This here is a map though, so I'm going to have to convert that to a JSON string. That means I need to change these single quotes to double quotes. And just remove these quotes here. All right. Now let's change this and let's make the word lion. The description can be king of the beasts. And we'll send our post request. And we get a response with an ID of 6. So that incremented the ID. Let's run another GET request to get all the words. And there it is. Sorted alphabetically, we have lion. What if we tried to post it again? We have entity already exists with a 409 conflict error. How about if we remove the word? Now we get a 400 bad request. Aqueduct automatically handles this for us because of the body binding. Okay, next we're going to handle put requests. This will be for update word. We already have the ID bound from the path, but to update the word, let's bind the body, similarly to what we did when we handled the post request. Let's just copy that from the post method. But I can change new word to, let's say, user update. I need to create the query now. It'll be similar to what we did before, so let me copy that. So the values I'll get from user update. And Aqueduct will only update the values if the user update, if the word has a value for some parameter. In that regard, it acts like a patch request. So Aqueduct handles put requests similar to patch requests. You really don't need to use a patch request when you're using Aqueduct, but you can if you want to. We don't want to update every word. We only want to update one word. That is, the word where the ID in the database is the same as the ID passed in the path. Now we can do the update. We'll await the query. We'll use query.update1 since we're only going to update one word. That will give us back an updated word that includes the updates, and we'll pass that into the response. Aqueduct will encode it as a JSON string and give it to the client. Let's try it out. Restart the server. Let's make a new request. This one will be a put request. Localhost port 8888 /words with an ID of 6, which is the lion. Again, we need to set the header for content type to application JSON. And the body will be a JSON string. Let me grab it over here from the post request. And let's change just a little. Instead of King of the Beasts, let's do King of the Jungle. Before I make the update, let's just test it out here. Let's do a GET request for ID 6. So you see it says Lion, King of the Beasts. Okay, now let's do the put request. The server passed us back the updated word, and it does say King of the Jungle. Let's just confirm that with a GET request, and yes, it updated it. The database has been updated. Okay, next we want to delete the word. We already have the ID bound from the path. The query will be similar to the update query. But there are no values to set, so we'll remove that. We'll just use the ID that's passed in is equal to the ID from the database. Let's perform the delete. We'll do await query.delete. That will pass back the number of rows that were deleted, which should be just one. Since we don't have anything else to pass back to the user, let's pass back a message in JSON form. So we'll make a map where the key is message and the value is deleted and however many rows were deleted. It could actually be 0, so we'll say word or words. And let's stick that message into the response. Aqueduct will convert it to JSON and give it to the client. Restart the server. Let's create a new request. It will be a delete request. Localhost port 8888/words, and the ID will delete lion, so that's ID number 6. And send. Yes, we get the message, deleted 1 word. Let's go check. Let's do a GET request for ID 6. Nothing there. But look at the status. We have a status of 200 OK. What we should really return is a 404 not found. That's a bug. Let's do a get all words, and yes, we see there are only 5 words here. Lion is gone. What if we try to delete ID 10? Deleted 0 words, but I still have a status of 200 OK. Again, what I should return is probably a 404 not found. This is also a bug. In the next unit, we're going to add tests to our database, and so those tests will help us define some of these bugs and keep them out of our server. That's it for this lesson. See you in the next.